Well, hi, and welcome to my shop here on February 26th. So I came into my shop this morning and said to myself, I'm going to make this radio work properly today. Today is the day. So the first thing I did was I got more curious about the antenna wire that's been fooled around with. This one here. And I got curious about this wire. And I started looking for the wave trap. There's a 456 wave trap in this radio. And I started looking at the schematic and tracing wires. And I got to a point where I said, this just is not working out. Normally I do all that stuff on camera, but I did this morning because I know this is a very tedious situation. So I got my document here and I started studying it more and more, and finally my eye found something. Alignment data on data sheet 33 for the R146. I ran over to Mr. Internet and he produced this document for me. Sheet 33. And on here is alignment for models 145 and 146, including this incredibly important diagram here. One of the things I did this morning was I spent a fair bit of time trying to sort out these coils and the ones that are up on top here, and which are which and which is what and who's going on and where in the heck is that wave trap coil anyway. Well, there is no wave trap coil. There is no wave trap in this radio. As it turns out, wave trap adjustment. And then in pencil someone's written R145 models pointing at it. The wave trap adjustments included only in chassis stamped with an S. There's no S here. It's supposed to be in this area anyway. It's not here. Never noticed that it actually has the IF frequency stamped right on here, 456. Well, the good news is, now there's lots of good news. Not only have I got this chart now, I can sort out what all these coils are. I've got the proper procedure for doing the alignment specific to this radio. That's all fantastic. The really great thing is, and I don't know if we should go through this, maybe I won't on video. If you have this radio, you can get this document. I got this from Pacific TV in British Columbia, just free on the internet. This is a really well written instruction for doing alignments. This paragraph here covers the rocking procedure, how that's really done. So let's talk about that for a minute. In all kinds of radios you're going to see instructions in the alignment to rock the dial while trying to maximize the signal. And they don't explain much about it. They just say, at this point, do the rock the dial procedure. And what's really going on there, in my mind anyway, from my understanding, is you're trying to align three things. So aligning three things is tricky, right? They're aligned. If one is high and one is low, and these are the only two you can adjust, and this last one is where it is and it's not going to move, you have to find a way to get these on top of that. But if you move this one on top of this, your signal will already be higher and lower and higher and lower, and you'll be convinced this is the place. When in fact, if you wiggled them all, you might eventually get them and find out, oh, a much higher signal here. So it's tricky business to do this, and the explanations are very, very poor. Not on here though. The proper way to do this is like rock one and do the other. Really, it's to move one and then wave the other one up and down, move it again, wave it up and down, and do all combinations you can come up with all through here until you actually do come across this one. So what I've been doing with radios is I don't really do this. I've only recently really understood what this was about. I use equipment that was not available back in the day to actually see the true frequency of the local oscillator, and this helps with the whole process of doing alignment. So I don't quite have to follow this rocking thing, but nevertheless, the engineer who wrote this took the time to write it in nice, clear English all the way through here. He's written it very nicely, so thank you very much. Now, given I have this, can I sort out what is going on in this radio? Well, That remains to be seen, but that is my goal today. So one of them is, well, let's just keep it rolling here. I was going to stop for a moment. Let's keep going. So, look. Why? Why are the way these cut? Why are they cut here? They're cut from here. So why aren't they long enough to go here? They're not going to get there. These are twisted together. There's lots of other green and black wires twisted together in this radio just like this. I'm pretty sure this is original. So what happened here? What happened to the screw terminal here? Why is this wire long enough to come right through? Maybe there was slack in it. I don't know. What would prompt this? I've tried to guess what somebody was trying to do here with this. And I don't really know. Maybe it starts with this terminal breaking and them fooling around with the radio until finally it's like this. I don't know. I really don't. My intention would be to restore this back to here. I don't think I can put a screw terminal or a terminal back in here, but to do something here too. Why not? There's supposed to be a short circuit bar that gets dropped in here. It's missing. Most of those are captured by one screw, so you can't lose them. It's not here. So did the person say to themselves, rather than wrap a small piece of wire here, I'm going to take the radio out of the cabinet, flip it over, cut these wires, cut out a chunk, and shorten them up and stick them like that. I can't imagine it. So there's a story here that's not coming out. We don't know what it is. We don't know how it got to be this way. So that's not terribly helpful. That's the best I could do on that. Now, given the fact that I know there's no wave trap, I'm no longer trying to trace the wave trap circuit, which is where my head was coming apart here this morning. So in fact, the little circuit tracing I've done so far suggests that this is the antenna wire. There's no problem. It's coming right where it's supposed to come, doing just what it's supposed to do. Yesterday, I found out that in 2 of the 3 bands positions, this one and this one, the 2 outside positions, the radio appears to be not working properly. But in the center position, it seemed to be working properly. So that's the hint. That's where I left off yesterday. That's where I want to start up today. Why would it be so different as you flip this band switch? Assumption being, a reasonable assumption being, no one's done anything to this switch. No one's gone in there and rewired it. Nothing like that has happened. It's a reasonably good assumption. So what are we left with? Defective component, maybe a short-circuited component. Maybe one of these capacitors has a short in it. I haven't tested them in any way. Maybe one capacitor that's involved with 2 bands, or one component involved with 2 bands. That's bizarre. The broadcast band and the high shortwave band. What would they ever have in common? When it comes to like what we're doing here, and we switch this, we're selecting from these coils up here. We're also selecting these coils. These are the oscillator coils. And up above are the antenna coils. 3 oscillator coils, 3 bands. 4 coils up here. Why 4? So I restored these antenna connections, and I spent some time examining the switch very carefully up close with a close-up camera, looking to make sure the fingers are moving when the switch is going through it and all that kind of stuff. It looks perfectly fine. So I've also tried a resistance measurement. You can see the clip here onto the antenna lead, switching the band, and then trying to find it on the coil up above. One of the there's a chance here that what's happened is these antenna coils are open up here. So I'm going to clean the switch. I'm using some really powerful cleaner here. That's no question about cleaning it. She's drenched. Okay, we're going to give the radio a try at this point. Not that I have any reason to think it's going to work any differently than it did. Okay, on the antenna, we're going to hook up the outdoor antenna. You know what, I'm going to stop the video and just get everything set up here. I got to get out of here, man. It's fuming. Okay, let's give it a go here. Set. Good. Through the dim bulbs. All seems fine. 113 volts. Got a bit of a buzz coming out of the speaker. Is that new? Well, geez, I had the volume right up full. So you see I have the antenna connected. I've chosen to connect it to the this connection, the dipole connection to start with. It's just quiet as can be. Oh, let's make sure this is up full. So I'm going to move the antenna from here over. And I have to put a link in. Should have got ready for that. Just any old piece of wire is going to do the trick here. The fact that I did this with a resistor doesn't mean anything. I'm just using the lead from the resistor. Get under there. Okay, that's the antenna. Doesn't do much. Let's hook up to it. Well, something coming through. Not exactly what we want to hear though. That's broadcast band. Wow, it's quite distinct, isn't it? What is on my antenna lead that makes that kind of sound in this radio? We have one band sort of working, we hear a little bit. The other band sounds like it's wide open, and the last one dead. Why? So I've checked these coils up here previously for conductivity as best I could, given what I knew at the time, and they all seem to be fine. Well, could it just be that I've just destroyed the alignment so bad that this is what the radio sounds like? Ooh, that's really good. So I'm touching the grid of the 6K7 here. That's the first time I've heard it come out like that. Let's try the working band. Now, you know, I've got it hooked up to the single input. I have the feeling, well, let's find out what's going on. Let's find out. Do we hear anything? What are the chances? So I think I'm on this 5 to, yeah, you know what, the only thing we'd ever pick up is a signal generator here. There should be lots of noise coming through. There's nothing really. Really. This band I found was hot when I checked it with the signal generator. But as for getting something off my antenna, wow, let's just go up to the top band, shortwave band. The radio's so quiet. It's not going to receive anything. There's that the hint about the minus, about the voltage on pin 8. On the A. Okay, I got too many thoughts in my head here. There's a pin voltage on the 6A8 that is supposed to be, I can't remember now, was it 24 volts, minus 24, and it's double on one band and half on the other, and correct on the band that works. I'm going to look into that on the schematic for a while. So I think I'm going to repeat a test I did earlier. I don't know if it even got on video. Where I'm going to try to test the continuity of these coils. So all these coils feed into the grid, and the other side of the coil is on this wire coming across to the two big beautiful green resistors. I know where these are. So I can read the resistance from this wire, this light wire here, to the grid, and as I flip the band I'll be reading through these coils. Yeah, it's good enough, good enough. Here we go. What's the difference? Is that it? It's supposed to be 0, isn't it? Or the resistance of the coil. Well, none of them show open circuit. Now, have I really done what I think I've done? Hooked on the grid here. The only way the meter can get a reading is because current from the meter is flowing down this way and somehow making it over to the other terminal lead over here. The only way you can do it, go through that coil, or go, yeah, it has to go through coils. There's 3 of them here, 2 and 3. It must go through them, and it does. But there's another, so I'm checking this side. What about the other side of these coils? So what exactly is going on with these coils? Okay, I've studied this at length here. Do I know fully what's going on? It's such a simple thing. I just have a terrible time with these switches here and stuff like that. So, but here's what I've reasoned out here is the grid is always fed from one of these coils. The grid is never connected directly to what's happening out here. So for instance, if you leave the link in and use the A antenna, you can trace it. You can see there's no way for it to get directly over here. It's got to pick on one of these 3, which are one of these 3 coils, and then the other side of it is simply going to the chassis. So all that's happening is the antenna signal is being selectively fed through one of these coils. This guy, this has got to be the AM coil. Look at the complications here. This is all part of it. Because there's only 3 pickup coils. So you can see the 3 pickup coils. This one, and this one. This is not a pickup coil. This is look at, and there's an extra tuning element here. This is a 3-section capacitor. This is one of the sections involved only with this band, which I can tell because this is in a short wave position. So if you picture this click, click, now it's on this wire, and this would be the broadcast. So that this schmozzle here is all about broadcast. Okay, so this, again, the signal coming from the antenna must pass through one of these coils, energizing the opposite coil, and then feeding up into the grid. I've checked the continuity of these 3 coils. I don't think I've checked the continuity of these 3. How can we do that? So the signal going from the antenna connection always passes through one of these coils before it gets to ground. So all we've got to do is just measure the resistance of this terminal to the chassis, flip through the bands, and we should see coil resistance or 0 each time. Really simple stuff. Okay, let's try that. I'm really at the point here where I just have to work my way through every possible problem, one step at a time, and eliminate it, so it's no longer a possible problem. So how we got the, so what we do is move one of these to the chassis. Take this guy off. And move this one to this connection, and we should see a 0, which we do, all the way down. My meter wants to work. Let's put it on a 2K. Oh, okay. Really not very reliable anymore. Okay, here we go. That's broadcast band. That's the next band. Oh. Okay, so now that's the top. Like, this is broadcast, first shortwave, last shortwave, wide open. Let's look back at the. Look back at the schematic here. Is this the whole thing? Is this it? How could it be it? If you're not on this band, the band with the supposed open, yeah, they're all the same. They're just the same thing, aren't they? So this, yeah. They're all the same thing. They're all grounded on the bottom. They have to be, if they want to accept a signal from the antenna. And this, of course, is not in this radio. This piece does not exist. In this radio, an open coil. So what? If one coil is open, that only affects the one band. And the band is the high short wave, not the broadcast. So when I put it in the broadcast, the ohmmeter was actually reading through here, up to here, down through this coil. And cannot read through these because they're capacitors. So we don't know about this coil yet. And then out this way, up into the ground. So we've proven this coil. We haven't proven this one yet. Anyway, this is the other side now. Yeah, but this is a special. This is a special. What I mean by that is I tested these coils already by making a connection over here and up there. This doesn't get involved in that. So this is still an untested coil. How do we get to it? We get on the top of this capacitor. So, these are directly in parallel. Why did they do this? Put this wire. Why don't they just show a ground right here? Or show it connected across to here? That would even be better. Why did they do it like this? So anyway, all I have to do is get across this capacitor, and I should be reading the resistance here. Okay, that seems pretty clear. All I have to do is get across that capacitor. That capacitor was the one with the E notation on it and a trimmer. So that's this one. So if I put my ohmmeter lead between here and the ground, we are reading that one coil. That's what I think. Between here and ground. 0. And it shouldn't matter where the band switch is that right? That looks like 0 to me. So we've now proven all the coils. Yeah, Okay, time to poke around, get some more information into my head so I can think of what to do next, because aside from just poking around, let's run the radio and we'll scope signals. And I think I'm going to do this with a signal generator, so let me get everything hooked up here and see what's going on. Oh, okay, let's see where this leads. So I'm on the broadcast band. I'm feeding in a broadcast frequency here of basically 1.1 megahertz. The radio's tuned right near there. The signal's going into the single wire part of the antenna system, and the scope is looking at the signal on the grid of the 6A8. So basically whatever is getting through the front end, making it to the first tube. What we're looking at on the oscilloscope, it's going through the tuning of the radio. So the radio has to be tuned to the signal I'm sending. So I'm going to tune the radio here. I'm watching the scope. And there it is. So I knew I was quite close. Come back. So there we are. That's a modulated, what it looked like on the, you can't really see it all that well on the camera, but there it is. You can tell it's there from the width. So we'll go up to the next band. The radio, and the radio's not operating while I'm doing this, by the way. So on the next band, we're at 3.5 megahertz. So if I bring my signal generator up to 3.5 megahertz, we should see something on the pretty close right there. 3.5. There it goes. See it? So that means the radio is responding properly to a signal on its antenna. It's delivering it to the grid. This proves the radio's working. Work right out loud. Don't get this wrong now. So now we're on the highest band. We're tuned to 12 megahertz. We'll go up to 12. We'll see if it shows up. Right around here somewhere. Oh, right past it. This is the second indication that the top band is not working at all. Now I've got full power over here. There's no more. Scope is as sensitive as it will go. It's just showing nothing. More likely to sneak it through on another band. So what are we finding out here? Am I going to be fighting multiple problems? Maybe that's what is making this so difficult. Multiple problems. So we know the coils are okay. Why wouldn't the signal show up on the grid if the coils are okay? Okay, well, what am I doing now? Now I'm still reading from the antenna terminal just to the chassis. And oh, wait a minute. Well, that's interesting. The way they've done this. These coils are grounded always. This one is only grounded when the link is in place. So take the link out. This coil has no ground. This switch just goes through the switch and down to the coil to nowhere. So if I'm reading from A to ground, as I switch through, these others are grounded. Two grounded, one not. It's a ground, and the top one not grounded. So there's so I've proven there's no short to ground on this coil. just proving more and more that this is not the problem. Oh my gosh. Basically, everything seems sound right up to the first, to the mixer tube. Coming out of the mixer tube appears to be the correct signals. I've sorted out the antenna here so that we know now. We just, what do we know? I have to put that link back in. Without the link, you wouldn't expect this radio to work on the top band, but it would work on the other two. That's what this appears to be suggesting. The link, the D, you know what? The D is only effective for the top shortwave band. Huh? They're saying if you have a dipole, it has to be for only one band. They don't say anything about that anywhere. You would think, okay, you're either going to use a wire antenna and go on the A, or you're going to use a dipole of some sort and go on the DG terminals. But when you switch, so if you have this switched to where it is now, a shortwave. Okay, so the antenna come in this, the signal coming in this way, let's say. So it's trying to energize this coil. So one side has got a ground on it. You have the live on the D. Comes in here. It's got to find a ground. Comes in here. Comes up. There's just, it comes back to the A. It's unconnected. Now what happens to the other coils? So we flip the switch one notch. Now we're on this center wire. Sorry for doing this, but I got to do it. So we come down through this coil, come back up, and you are encountering a ground. They're done differently. I've seen this. Okay, it's always a ground here. Only a ground on this one when you put the link in. You only remove the link when you're using a dipole. The dipole is only influencing the top band. Somewhere it must say that. Somewhere in the write-up on this radio. That's weird though. That means you're using, like, okay, so you can use a dipole or a loop antenna for the broadcast, but then you use a long wire for shortwave. So you tend to hook the shortwave up to the A, the long wire to the A, and a small loop focused on the broadcast band, but the loop is hooked up to the shortwave band. Or the other way around. The only time this loop can work now, you put a loop on here, or a loop antenna, it won't do anything on two bands. It's always back to the A. Huh? What? I've got to find the user instructions for this. Not going to read. Wow. Okay, more of the puzzle has come together, and I've read this very carefully. And in there is a statement in the calibration effort here. When you get to band number 3, that's the high shortwave band. Turn the range switch to the extreme counterclockwise. Be sure the D and the G terminals on the antenna strip are connected together. But by then you've already done band 2 and band 1. They didn't say anything about make sure the short is in place for D and G. Well, now I know. If you want to use this antenna input, it's only going to work on the top band if you have the short in place, because the ground has been removed otherwise. Putting the short in, it just puts the ground on this bottom coil. So what they say up here for doing the alignment is hook up to the A wire, that's this wire, the antenna wire, and make no comment about the short back here at all. Make no comment until you get all the way down to here. Then it says, hey, make sure those are shorted at this point. The antenna terminals have a D. D stands for doublet or dipole. Loop has an L, not a D. So I think what the designers of this radio were thinking quite rightly. No one's going to use a dipole or a doublet antenna on such a low frequency like the broadcast band, because your antenna would have to be miles long, or the long wave band where your antenna is still hundreds and hundreds of meters long. No one's going to do that. But on the higher frequency short wave band, you could hang a proper doublet type antenna in your backyard. Doesn't have to be thousands of feet long. So they've made an allowance for people who want to do that. If instead you don't want to use the long wire on high short wave, you want to use your fancy dipole, this radio will accommodate it. That's why it has a D on the back and not an L. So I've never thought of these things before. I've never really thought through this. So it all makes sense now, how this is done. So the only time you would ever use the doublet antenna is doublet antenna terminals here is for short wave on the high band. Okay, got that all straight. Straightening out my puzzle pieces here. So what does that all mean in terms of what's happening with this radio? I don't know that part yet. I still have more coffee to drink and think more. Okay, a little bit more thought. So what that would mean is, if the link is not in place, then you can't successfully feed a signal through this radio. You won't be able to pass a signal through the coil. So I have the ohm meter still hooked up. It shows the coil open circuit. And if I put a ground in here, Lordy be, there it is. Okay, I think I actually understand the little tiny bit of this radio that's in the front here. It's taken a long time to really get a grip on it. Now, how's this all? This is going to influence the way I'm testing things, because my puzzle pieces were wrong and in the wrong place. Hopefully now I've got them in the right place. If I go through and do testing, it'll make more sense to me. Maybe help me track down really what's going on here. Maybe. So if we continue with the resistance test, we see a 0, we see a 0. There's no reason to, almost a 0. It should work. If I go up on the high band, I now know I need a short in here. What if you're on the other bands and you have that short in place? I don't think it does anything whatsoever, because they already have the ground. It's just up here where it's going to have an effect. So that means when the previous person had shorted the wires here in a very permanent way, that's no problem. You then remove these terminals from the back, or access to them, and the terminals are still sitting here. And you're left with just one place to hook up the antenna. And that's going to work all around. So I'm going to put a link in back here, and we're going to carry on. Best to have a link in on this radio. That's kind of the bottom line. So I think what I want to do at this point is just survey the radio again, just operate it and see what happens. Big signal not appearing. And I just can't imagine how is this going to work on the next band. Can't imagine. Around 11. The radio's just silent. So I really don't have to say that. It's kind of obvious, isn't it? Okay, same thing, passing the entire front end again and just going right onto the grid, the 6A8. Single frequency coming from the signal generator. I think I gotta ground it. Whack! Very powerful, I'm gonna turn it down. Who's doing that? That's kind of interesting. It's this up here. So a grid cap connection is kind of wonky up here. It's not as secure as it should be. Kind of a temporary thing. A little better. Okay, man. Pumping in the tuned signal. Which band am I on? Okay, so we're in the top band, around 11. Pumping in around 11. Oh my, I just totally killed this radio. It's just gone. It's gone away. 3. Blaster of a signal. Oh, here we go. Here we go. Now, why didn't it do this last time? 3.48. That could be 3.48 right there. This is a moderately strong signal. That's a moderate signal. Volume up full. Yeah, it's, you know, she's not performing. What could it be? Now, let me put it back on. I'll feed the signal into the antenna. I mean, that really screams out that there's a problem here. All it's doing is going through a coil, going through a transformer up to that grid. Why have I been able to sort of prove the whole thing out and then come along and try to send a signal through and nothing happens? Pourquoi? Pourquoi? That's French for I shouldn't really try speaking French. Well, just a real mystery. It's just really mystifying. Okay, stop again. Okay, so I have it on the broadcast band. They really haven't done anything except just make sure my signal generator is putting out its maximum power. Voila. That's 1140. And on here, you know, that could be 1140 for sure. It's getting through, but very, very weak. Very, very weak. If it were well, that doesn't say it's open. That says it's not open. So I've tested this numerous times now. Every time I get the same result. The coils are good. Coils are not shorted together and they're not shorted to ground inside the can. Transformer, you know, like a possibility here is some turns inside one of those transformer coils have shorted. So instead of having 1,000 turns now, it only has 600. Effective turns. It's highly unlikely to have happened. Highly unlikely. Okay, so I've got the signal generator on the A antenna wire band switch broadcast right now. Got this fixed, still temporary, but it's reliable now. 455. Right there. If I put on full blast, you can hear it. Down 10. just roars right through in that center band. Not roaring through on this band. Yeah. IF. So I mean, in the one setting, it really blasts through there. How far out can this transformer be? If it comes through loud and clear there on one. Isn't this where this whole thing started? I tried tuning this transformer and it had no response. Isn't this where this whole deal started? What's happening there? What is it about this transformer here? A stupid thought went through my head there. I won't share it. Oh! What's happened? What happened? Quick, man, take action. Wow. Okay, is the radio working? Is that what's happened here? It may be working. Let me get this out of here. Put the real antenna on it. Don't do anything else. Don't do anything else. Oh, that didn't make any difference. Okay, keep going, keep going. Doesn't sound like it now. You hear a pitch going up? That's not normal. Bum of a radio. That's this, now. This sounds good. This is, hey, all three bands making sounds. That sounds like a radio. It could be a terribly adjusted radio. I think I hit it. I think I've hit the mark. There's something going on up here. Don't bang on it. So I'm going to end this video thinking I've hit the mark. Once again, I think the next step, I have to remove this right out of the radio. Take it out and look at it and poke around with it and do stuff to it and try to figure out what exactly has gone wrong with the transformer. That's tomorrow's deal. So my intention, you know, I said I was going to make this radio work. I think I did at the last minute there. I'll call that success for now. Tomorrow, okay, we'll go at the coil there. I've decided to carry on, so I've disconnected the 3 wires here. Should be able to pull the transformer right out of here. There it is. Okay. So when I made this connection, I'm connecting to a, I don't know how many wires are in here, but it's not a single conductor. It's pretty sure it's 4 or 5 very light wires wound, like twisted around each other. It's a cable, and I soldered to it. Of the 5, 6 wires that might be in it, how many of them actually got electrically connected? I don't know. I like to assume they all got connected, but maybe not. And they're insulated between each other all the way through this coil. So I finally soldered onto one wire of the bundle. But I have only one wire in this coil. I wondered about that. Now what else can be wrong here? So I was pushing pretty hard on one of these. Just putting a twist in here. Maybe it just shorted to the can at that point. It looks like there's almost no clearance. And I didn't put the cardboard in. But there was no evidence that it was actually shorted. Ever. Well, I don't know. I don't think it's shorted to the can. Well, here it is. What to do? So I know this is the primary side because it has the red wire, and this is the other wire. I can make this coil a little more stable here. Oh, there's an internal nut. This is the one that's come loose. That's much better. That's way better. In fact, because this nut was loose, the whole thing could move relative to here and just stress this connection. Maybe that was the original problem. Not with that. I suppose you could get a short around here, you know, from dirt, but I wouldn't count on that. These terminals are integral. This is the same piece of metal here as what is rising up here. So there's no connection in here. The connection is here only. This is really the only wonky connection. Oh boy. Somehow I thought something obvious would hop out here. Clearly nothing is obvious here. Okay, let's do some resistance tests. On the terminals. 80 ohms. 10 ohms. These coils look to be about the same size, and one of them has 8 times the resistance of the other. That's 11 or 12 ohms. That's 80 ohms. So is this because there are 8 wires in that bundle and I only soldered onto one of them? And so I get 8 times the resistance in this coil than this one. I guess a very, very close look at this might answer that question. Let's just try with the camera here first. magnification I need here. Maybe. Kind of wrap the extension wire around the bundle and then tried to solder it. Well, you really can't see much with this. Okay, just in the hopes of seeing something, I got it under my microscope, and here's what we see under there. So coming in from the left side is the extension wire I soldered on. That's the single strand from a piece of cable, single strand, and then that is kind of, I don't know what to say about it. This connection tests as having continuity, but look at it. Sometimes I think when you're trying to solder to these kinds of wires that have very, very thin coating on them, looks like they're not coated, but they are. In the end, you put like a solder blob on them, and the solder contacts the cut end of the wire, which is not protected with any kind of coating or anything. So when all those wire ends kind of stuck together and then soldered on top of. Now you can remove the coating. One way is with heat. You put a match to it. Wouldn't recommend that. There's no wire to spare here, and putting a match to these wires, they look a little substantial there under the microscope. They are so tiny that match heat will melt them. And so to me, this is just a question of continually resoldering, and then try to get that resistance reading down, similar to the other one, down to 10. And maybe that's the key to repairing this. So how many strands do you think there are in the wire? Is there another place? There's another spot I can kind of look at the wire over here. So this is just another. How many are in there? 1, 2, 3. Oh, it looks like 10 or 12 in there. When they make this, of course, they make it. They bring that multi-conductor cable there, and they solder it very carefully onto this terminal, which is a little out of focus. And then the radio builder solders his wire onto that terminal, hopefully not disturbing the work done by the person who built the coil, assuming they're not the same people. You can even see the coil wire where the factory did it. They didn't even like bring it down tight to the terminal there. And this is probably because, do you think they're looking at their work with a microscope in the factory? They might have a magnifier to look at it, but there you can really see the number of independent conductors in there. Right at the terminal, 5, 6, 7 of them. Okay, now we go back to the part I'm working on. Uh-oh. Gotta get it down lower. Oh, I'm not looking at the right spot anyway. Here we are. I should try to mechanically move those free wire strands down around the wire I want to solder them to. Just increase the odds of making a connection to them. Wow. Wow. Okay, let's try it with a piece of stick. absolutely, really no visibility, well, barely any visibility by eye on this. There's a wire here I can see though, down under. Like this wire's not going to cooperate. Okay, let me watch. I'll bring it up on the TV. Oh my gosh. It's so hard to look at the TV and get a perspective on it. I think most I'm going to do here is push these wires away the way I'm doing this. I kind of come at it. Let me try something a little. That stick is too long in my shop here. Under the microscope. Not a lot of room under the microscope, you know, to maneuver things. So here's another piece of wire. Oh my gosh. Looks like some kind of lot. Look at all this wire is just hanging down here. It didn't get soldered at all. Oh, what's that blob? That's interesting. Now that's probably just junk from me previously. Push it all together. And then just hit that with a big whack of solder. And let's do it under the microscope. Solder. Okay, who took my solder here? Solder is gone for a walk. There it is. Hiding from me. So I'm going to get myself all lined up here. I'm just doing it till I switch the camera. Okay, let's see what happens. Bring this gigantic hot iron in there. Okay, solder in place first. Okay, soldering iron. Pile it on. Did I pile it on? Did I smoke up my microscope lens here? Don't think it really worked yet. Drop the solder on there. Looks exactly the same as it did. It looks different to my eye, but drop the solder on there. Come on, big blob of solder. Am I even soldering the right thing? I can't get the solder to blob on. Come on. Ooh. It's not exactly blobbing on. I guess that's smoke blowing by the lens, is it? I don't know what that is. Does that look any better soldered? No. Huh. How come I can't blob the solder onto it? You know, maybe I've had success. I should make a resistance measurement here. So you're doing this and having actually had success but not realizing it. So we had measured 80 last time. Let's see if it's any different. Watch this, it'll be open circuit, that's what it'll be. Okay. Any different reading would be encouraging. $80. Isn't that kind of the same? I didn't make any difference on that. Why am I getting all these readings? Never goes below 80. Let's try right here. 80, 80, 80. And the other one. 12. 80 and 12. The chances these two coils are identical are not terribly likely. Let's look at the wire on this upper one. See what see if it looks like it's really different in some way. And my stomach's growling here. Maybe right here. Wow, look at the wire right in the coil. Yeah, look at the wire right in the coil. See what that looks like? Well, now I'm going to look at the other coil. Go from there to here. Oh, it's out of focus. Wow, if they're different, it's not much. You read a different resistance. Looking with my eye, this coil might be just a little, that's my finger, this coil might be just a little bigger than the other, but not 8 times bigger. So what am I to conclude here? Either the coil is 80 ohms and it's done, and I'm wasting my time, or I've still only managed to connect to one wire, and if I got the rest of them connected in there, we would see the resistance come down. I'm not even sure of that. Pretty sure of that. Not fully sure. I'm not fully sure of anything anymore. I'm sure of one thing. It's way past lunchtime now. So what I've done here is I've connected my sweep generator to the primary terminals for the primary coil, and I've connected my oscilloscope to the other terminals on the secondary, so we can see what's happening here. Okay, so what I've done here is I've set up my sweep generator and I'm feeding it in on these wires onto the primary. And from the secondary coil, I've got my oscilloscope connected so we can see what this looks like. I've got the sweep generator sweeping through what should be the tuned frequency of the transformer, which is 455 kilohertz. Let's see what it looks like. Get a closer look. It's jumping around probably because something's a little loose here. Let's just see. Oh, I don't know why it's jumping around like that. Certainly wasn't doing that a moment ago. Just fool around with a few things here and see where the instability is coming from. This is the output level from my sweep generator. That looks like You know what that looks like? That looks like instability here somewhere. Well, it was rock solid just before I turned on the camera. Yeah, I think it might be this. Look at that. We get it solid there. Good. We'll leave it like that. Let's have dirt in some of these settings. Some of these controls. More towards the middle. A little hard to tell the frequency now without seeing the ends. Can we shrink this a little bit? Oh wow. It's interesting. Just a few settings on my scope. Well, the ends are, if I can make them fairly equal distance here. As far as I can go. Well, okay. Well, we'll just do it. We'll have to do it roughly here. So I think that's roughly in the middle. By that I mean this isn't in the middle. The start and the end are balanced. So we can read this frequency. It's between the ranges that we're ranging on. And what are we ranging on? So we're going from 355 kilohertz up to 618. 350 to 618. 350 to 618. So it's 300. Roughly, a little less than 300. And there's 1, 2, 10, 330 a spot, 30 a space. Wow, this is just so inaccurate. So, but 30, so we're starting again. The start was, let me just check it here, 350. So 350, 30 per square. 1, 2, 3, 4, 5, 6, 7 squares, let's say. Out to the start, 7 squares, 21. So you add 21 to 350. This is crazy. You get 500 and something. That's crazy. Well, here comes the interesting part now. What happens if I try to adjust this transformer? Drop the camera a little bit. Clearly affect the resonance by hooking stuff up. See how it's not just going away, it's moving, over. So very sensitive to this, and my scope input impedance is really throwing it off. That's a times 10 setting there, isn't it? That's a times 10 setting. It's a higher impedance, less interference with this coil. But how far off this really is from where it would be if it were in the radio, I don't know. It could be way off. I don't know. As I had not really experienced of fooling around with these too much. So this would be the this is the secondary side. What happens if you turn the capacitor? And what if you do the primary side? This is what was happening when I tried adjusting the when I was trying to align the radio. That one side had an effect, the other side had no effect at all. Is the capacitor stuck? I don't know, is that? No, I can see it expanding. Let's reverse the connections around just in case that's having an influence here on how this test appears. Again, I'm operating with not an awful lot of experience. I guess that's kind of generally true, you know. for all of us. Oops. Yeah, that's right. So this is the secondary. So I reversed the leads basically. What happened to the effect? So there's two resonant circuits here. There's two capacitors, two coils. They can each resonate at different frequencies. I mean, the object is to get them to resonate at the same frequency, 456 in this case. I see a very distinct peak when looking the other way around. I don't see anything now. Let's expand the sweep really big. See, that didn't help. So I basically expanded the sweep but shifted it up at the same time. So now we're going to shrink the sweep but shift it down. Maybe we'll capture it then. Maybe a little further. Maybe there's just no resonance in this. I was thinking about the 80 ohm resistance and the 10 ohm resistance, and I had assumed that the 10 or the 12 was correct and the 80 was wrong, but maybe it's the other way around. Could be the broken lead problem here. It's just a sideshow from the real problem, which is on the other coil. Must be some resonance here somewhere, wouldn't there be? Shouldn't there be? How can there be no resonance at all? Wouldn't it just be that it's just so far away from where I'm sweeping I don't see it? Oh, look at that. How do you like that? So this one was way out to the side, but now it's roughly in the middle like the other one. So what happens if I change this one now? Oh, ooh, what's happening there? I'm touching something? Well, what is it that's doing that? Could be something very innocent. My fingers in particular. Yeah, maybe I was just touching even with one finger. Look how sensitive this is. So that's just destroying the Q in the circuit and shifting the resonance. Now, I got this all turned around here. Adjust this one. This is quite tight. Now it's not having an effect. So I would have thought, or did I even think, getting both these to resonate at the same level increases the throughput, I would think. So why is it just sitting there so stable when I do the input side? My finger's in the way. It's not quite what I was expecting. Let's flip it around again. This is the primary side. Off to the side there. Now, once again, I'll fool with the primary, but I want this side. I want to return it after. Okay, just leave it. It's the other side that's going to really. So that's roughly where it was. I just jumped there. I jumped again. It could just be this. Could just be that. It didn't really jump. It just disappeared momentarily. I don't think there's anything particularly wrong with this. I mean, where's this resonating? Or where's that peak? Let's put it that way. So now, let's see, the middle of the sweep is 480. So, you know, roughly around 500. Showing too high again. But it shows it's adjustable. Even if I have to rotate it, you know, this way or that, at least I've learned both sides can be adjusted. And it seems to be functioning the way it should. So, you know, the problem with this situation is you look at it and go, well, I haven't really done anything to it. Should I put it all back together again? Stick it back in the radio. Only to find out you want to take it out again. What else can I possibly do with this? That's a good question. Okay, what I've done is I've hooked up my SDR radio here and just have the antenna, single lead antenna to my SDR, and on the input side I still have the sweep generator sweeping away over there. So we're going to look at the SDR. I'm going to just put it right on the screen there. Don't jump to too many conclusions too quick on what you see here. Okay, so that's a pretty wild looking thing. So if you look at the waterfall display, the shaded area now, that's basically going roughly from 300 to 1,000,000. That's the sweep. So if I change the sweep, the width of that will change. Right in the middle, not in the middle, a little to the right of the middle, you see something going on there. Goes up, goes down, comes back up. Kind of looks like a hysteresis curve or something like that. Part of what's probably going on here is the SDR itself is trying to handle this signal, all those signals you see. It's trying to use its gain control and things like that. So it's probably disturbing the image quite a bit. The SDR is doing stuff to the image. Nevertheless, shows us something. Now I'm going to start turning these capacitors here. And I shouldn't have to get my hand near it anymore. So here we go. So I'm turning the capacitor on the side the SDR is watching. You can clearly see the resonant point moving. Now 600K, 500, the whole thing just fell out of my chuck here where I had it so wonderfully set up. Okay, well yeah, it's amazing. Let me continue turning this down. Oh, fell out of my chuck again. Yeah, maybe not the best arrangement here, Jim. What if I did it like that? I don't know. Let's find out. Okay, here we go again. Trying to turn the screws. Just fell right out. A dumb arrangement. I have a dumb arrangement here. Okay, we're going to forget all that. So I got my fingers all over this thing again. Son of a gun. Now I'm going to tighten this up further. Ooh, we can't go much further than this. Really tight and right around 455, but the way I have this equipment connected to it, it doesn't mean too much. But in this case, to get it there, very tight. Now I'm going to flip the leads around to the other side. Like flip the whole thing around. See what it looks like in reverse. Okay, okay, making the connection now. Well, it looks pretty similar. I think I only adjusted one of the capacitors before. I didn't try them both. Okay. There was one. Definitely moving. And that's the one that the SDR is listening to or looking at. Or we're looking at now the other primary, which I cranked down pretty tight. Interesting. I would have thought that if you gotta make both these coils resonant at the same spot, you get a big You get a big peak, and it just doesn't seem to do anything every time I do this. What's the lesson here? When you do the secondary side, the resonance travels. Again, I don't know if this would be true. I don't think this is true in a radio. I certainly have the impression when you do an alignment, you're moving both coil resonant frequencies back and forth, for sure. So it's probably just a kind of a bogus way of doing this. A little experiment. Okay. Okay, I think I'm going to end it here for today. It's 3 o'clock in the afternoon now. So with this out of the radio, maybe I have an opportunity to do something with the radio, because this is disconnected. I don't know. I'm going to think some more about it. Chances are tomorrow that's just going back in the radio, and we're going to face up to the same problems again. Thanks a lot for watching.